Good morning. Today we'll be looking at the third topic of the chapter sounds. Today we will discuss how can we see sounds. Why do two instruments sound so different? For example, a flute and a trumpet, both of them have air columns. The air in the column is made to vibrate and produces a musical note, but they both sound so different. The reason is because both of them have different shapes. The air column have different shapes. That's the reason they both produce different sounds. An image of notes can be produced by playing an instrument next to a microphone connected to an oscilloscope. The device that you see on your screens is called an oscilloscope. Keep that in mind. It consists of an oscilloscope which is connected to a microphone. This person playing a trumpet is making the air column in the trumpet vibrate, making the air around him vibrate. These vibrations are picked up by the microphone. The microphone receives the vibrations and converts them to an electrical signal. The electrical signal can be seen on the screen of an oscilloscope in this form. A signal generator can produce pure notes that have very simple shape when displayed on an oscilloscope screen, as shown in figure 12.9. This is an oscilloscope screen. From here, we can find out some very important measurements. For example, the time period. The time period is the time for one complete vibration or oscillation. One complete vibration means, let's say, if the wave starts from this point, it goes to the top, comes to the mean position, goes below, comes to the mean position again. This is one complete oscillation till here. Okay, be careful. Don't only measure from here till here, or not only the bottom part. It has to be from the mean position, goes up, all the way down, and then back up. The time taken is known as the time period. Or if you start from the top point, all the way down and back up again. If you start from the bottom point, all the way up and back down. All right? Because this is the time for one complete oscillation, it is measured in seconds or milliseconds. Frequency is the number of vibrations in 1 second, or you can say the number of vibrations per second. It is measured in hertz. 1 hertz is 1 vibration per second. Using these two definitions, we can say that frequency equals 1 over time period, or time period is 1 over frequency. I would like you all to write these definitions and the units and the formula in your notebook and memorize them all. Okay? Also, what do we mean by pure notes? A single frequency wave is called a pure note. So a wave whose frequency does not change is known as a pure Then you can see on your screens another important term called amplitude. Amplitude is the distance from the mean position, that is the middle, to the top, or from the middle to the bottom. From here till here, amplitude. Or from here till here, amplitude. This is the distance from the mean position till the top of the wave. From the mean position till the top, or from the mean position till the bottom. Because it's the distance, it will be measured in meters, millimeters, centimeters, and so on. From here, you can write the definition of amplitude in your notebooks. Remember, the amplitude is the maximum extent of vibration or oscillation measured from the position of equilibrium. This is the position of equilibrium or the mean position. From here till the top or from here till the bottom. I repeat, from here till the top, amplitude, or from here till the bottom, amplitude. It is measured in meters, centimeters, or millimeters since it's the distance. Now that you know about frequency, time period, and amplitude, we can differentiate different types of waves based on their different frequencies. Higher pitch means higher frequency. Now, first of all, what do we mean by higher pitch? A shrill sound has high pitch. Means a man's voice has lower pitch as compared to a female's voice. Shrill sound, higher pitch. Female's voice is higher pitch. Male's voice is lower pitch. All right? Now, high pitch means high frequency. Look at this figure 12.10. A. Look at these two figures. You can see that both of them have the same amplitude, means the distance from the mean position to the top. The distance from mean position to the top is two boxes. So the amplitude is the same. However, in the first one you have 1, 2, 3, 4 waves. In the second one you have 1, 2, 3, 4, 5, 6, 7, 8 waves. So more waves per second, less waves per second. This figure is higher pitch than this one. Okay. Next, louder note means greater amplitude. Observe figure 12.10b. You have two waves. Both of them have same frequency. You have 1, 2, 3, 4 waves here. 2, 3, and 4 waves here. So their frequency is the same. The difference is in their amplitude. Amplitude is 1 from the middle to the top. The amplitude from the middle to the top is 2 boxes. Because they have different amplitudes, they have different volume. Or the second one is a louder note as compared to the first one. Human beings can only hear a certain range of frequencies. We can hear from 20 Hz to about 20,000 Hz. 20,000 Hz is the same as 20 kilohertz. Observe how kilohertz is written. The K is small case, H capital, and Z small case again. The upper limit of hearing decreases about 2 kilohertz, that is 2000 hertz, every decade of your age. Means that after 10 years, you can only hear from 20 hertz to about 18,000 hertz. 10 years after that, you could only hear from 20 hertz till about 16,000 hertz, and so on. Sounds that are higher pitched, that is more than 20,000 hertz, we cannot hear them, they are called ultrasound. Sounds that have low pitch, lower than 20 hertz, we cannot hear them either, are known as infrasound. Now, a dog's whistle, we humans, we cannot hear it. It is ultrasound. It is sound with frequency higher than 20,000 hertz. However, dogs can hear it from a greater distance. For your assignment today, I want you all to solve from questions 12.6 till 12.11. You will find them on page 173 in your textbooks. I want you all to solve them in your notebooks. All the best.